All right, Algebra 2, let's get going with Unit 5, Day 1. Pause the video, fill this information in, or maybe go back at some point in time to my Canvas page, look at the key, and then fill this in. But I will make sure and explain all of this as we go along. Moving down here to these two graphs, what they want you to do is find the minimum or maximum value. We're going to start by, let's identify what the vertex is. The vertex here is the ordered pair 1, comma, -1. And this here is going to be a minimum. Our graph is never going to go any lower than that point there. The minimum value occurs at -1. That's what the lowest y value is going to be. That also happens to be this value of our vertex. Over here, the vertex is right there. That's 1, comma 1. This one happens to be a maximum. It's never going to go any higher than that. So we have a maximum at the y value, +1. Example 1 here. Let's first identify what our a value is, 1, our b value, -4, and our c value, 1. Now, if your a value is 1, that tells you your graph is going to open up. It's going to be a positive graph. It's going to open up like this. Axis of symmetry. If it's written in standard form, which this is written in standard form, you need to use this formula. -b over 2a equals x. So let's start doing that. -b over 2a equals x. And if we simplify, a negative times a negative is a positive. 2 times 1 is 2. And then 4 divided by 2 is 2. So that's our axis of symmetry, and you want to write it as an equation. X equals 2. Now that we've identified that, we can find the vertex by taking that number 2 and substituting it back into our function everywhere we see an x. And then you just start solving. We square that, we get 4. We multiply that, we get -8. And now 4 minus 8 is -4. And -4 plus 1 is -3. So now we know what our vertex is. Our vertex is, remember, we plugged in a 2, comma, and our result was -3. Y-intercept. Now, the way you find the y-intercept of any function is everywhere you see a 0, or I'm sorry, an x, you plug in a 0. If it's written in standard form, however, it's going to be your c value. So not a lot of work to do here if you just know that rule. In order to identify the roots, what you do is you take your function, you set it equal to 0, and you solve for x. X squared minus 4x plus 1 equals 0. Well, this cannot be factored, meaning we have to use the quadratic equation. So I'm going to start doing that. Opposite b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Plus or minus. Well, if you simplify what we have in the square root here, that's going to give you 12, which is our discriminant, by the way. 12 is the discriminant. What does that reduce to? Let's see. 2, 6, 3. All right. So we can simplify a little bit further. The square root of 12 reduces to 2 root 3. And now we can reduce one more time. All of these outside numbers are divisible by 2. So our roots, our x-intercepts are 2 plus or minus root 3. Maximum or minimum? Well, we can tell that by the direction that it's going to open. It's going to open up. Therefore, we have a minimum at. And as long as you know this value of the vertex, that's your minimum or maximum value. Your domain for every single one of these is going to be -infinity, +infinity. If it is a quadratic function, it will be -infinity, +infinity. And your range is going to consist of this value of the vertex here and the direction that it opens. So since it's opening up, that means it's going to positive infinity. So we want to start with our minimum value. Let's start with the minimum value, -3. And then it's going to go to a positive infinity from there. And if we graph this, let's start with our vertex. 2, -3. From the origin, go right 2, down 3. And now since our a value is 1, what we can do here is we can do that trick that I showed you last unit. You can go right 1, up 1. You can go right 2, and then up 1, 2, 3, 4. Go back to the vertex, you can go right 3 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if you just remember that points opposite the vertex reflect, you can plot the other ones.
Move over to side 2.
All right, our a value here is -1. B value, -2. C value, +7. So the direction this is going to open, since a is negative, it's going to open down. Axis of symmetry. It's that formula, -b over 2a. Negative b over 2a. And this is going to reduce to -1. So we know our axis of symmetry is x equals -1. To find vertex, we're going to take that -1 and we're going to plug it in for x there and there. Okay, now -1 times -1 is +1. Negative times a negative is a positive. Now we're going to distribute that negative. And if you combine your like terms here, we're going to get 8. So our axis of symmetry is -1, comma, oops, comma 8. -1, comma 8. Our y-intercept, if it's in standard form, which it is, and you know the c value, that's your y-intercept, 0, comma 7. Your roots here, they would be irrational once again, and I don't have a terrible amount of time to be shooting this video, so I am going to just give you the answer. Just know that you would have to use the quadratic equation in order to find them. And if you do the quadratic equation correctly and solve, we get -1 plus or minus 2 root 2. Those are our roots. Maximum or minimum. This one is opening down. It's going to open down like this. So we're going to have a maximum at that value of your vertex. We have a max at 8. Remember our domain, -infinity, +infinity. The range this time, since we're opening down, we want to start with -infinity and then end with your maximum. Our maximum was 8. You want to do interval notation from minimum to maximum. And then if we graph starting with our vertex, we're going to go left 1, up 8. Since our a value is, well, -1, we can do the trick that I've shown you up to this point. Let's go left 1, down 1. Left 2, down 4, 1, 2, 3, 4. And that's going to be enough for now. Now on the opposite side of the vertex, let's go right 1, down 1. Right 2, down 1, 2. All right, if you want to pause the video now, fill in those blanks. Now we have a function written in factored form, and the direction this is going to open is up. Here's how I can tell. Well, first of all, the x values are both positive, and the number in front of the parentheses is positive. So that means if we were to FOIL this out and combine like terms, our a value would be positive. Our axis of symmetry, well, I don't know that yet, but we're going to need to use this formula. If it's written in factored form, this is the new axis of symmetry formula that you're going to need to follow. But before we do this, let's do the roots first. because if it's written in factored form, it's very easy to identify what your x-intercepts are. So let me write down what this function is. 2 x minus 5, x minus 1, and then we set this equal to 0. Well, since this is completely factored, all we have to do is set all of our factors equal to 0. Now 2 does not equal 0, so that's not an answer. Here, you'd have to add 5. Here, you'd have to add 1. Those are our x-intercepts. Those are our roots. 5, 0, 1, 0. Those are also our p and q variables. So now let's find that axis of symmetry. P plus q divided by 2. P plus q divided by 2 is going to give us our axis of symmetry. And now let's simplify. So our axis of symmetry is x equals 3. Now that we know what our axis of symmetry is, we can find our vertex by taking 3 and substituting it there for x. Okay, now let's do parentheses first. Now you can multiply. If you multiply all that together, we get y equals -8. Now we know what our axis of symmetry is. It is 3, -8. To find the y-intercept of any function, everywhere you see an x, you want to plug in a 0. And then parentheses first, 0 minus 5 is -5. 0 minus 1 is -1. If you multiply all of that, we get +10. That is our y-intercept. Maximum or minimum? This is opening up, so we're going to have a minimum at that value there. Minimum at -8. Domain, -infinity, +infinity. And our range, minimum to maximum. It's opening up all the way to +infinity from there. And now we can just start graphing all of our critical points here. Oh, let's see. How about we start with y-intercept, 0, 10. Right there. Our roots, 5, 0, 1, 0. And our vertex, 3, -8. And that's enough big graph. It's not very good. But there it is. All right, example 4. This is going to open up. How can you tell? Well, the x values are both positive, and there's no negative in front of our parentheses, so it's opening up. Axis of symmetry, p plus q divided by 2. Well, we have to know our roots first. If you set each of these equal to 0 and solve, this is what we'd get. Those are our x-intercepts. So now we can find our axis of symmetry. P plus q divided by 2. That is our axis of symmetry. X equals 1. Now that we know what our axis of symmetry is, we can find the vertex by plugging in a 1 everywhere we see an x. And then simplify. Parentheses first. 1 plus 1 is 2. 1 minus 3 is -2. Then you can multiply. We know what our vertex is. It's 1, -4. Define y-intercept of any function. Everywhere you see an x, plug in a 0. Then solve. Parentheses first. Now multiply. -3. That is our y-intercept. Minimum or maximum? Well, it's opening up, so we're going to have a minimum at, that's the value we need, -4. domain, negative infinity, positive infinity, range from minimum here to maximum. It's opening up, positive infinity. And if we were to graph, let's graph our critical points here. 1, -4. Y-intercept 0, -3. And how about our x-intercepts? -1, 0, 3, 0, and we'll call it a day there. All right, let's move on to the next page. Now we're going to be graphing functions in vertex form. In vertex form, it's very easy to identify your transformations. So all of our functions, if it's a quadratic, the parent function is y = x squared. Your graph is going to start at the origin 0, 0. Now that we have introduced some transformations here, they're not going to start at the origin. Well, mostly. We'll see though. This one here, from the origin, this is going to shift up to, that's what a shift vertically up to is going to look like. Here, this is a vertical shift down 5. Anything in parentheses means your graph is going to shift from the origin left to right, and it's opposite of what you think it would be. Why is it opposite? Because you're supposed to set it equal to 0 and then solve it. So we're going left 5. Here, we're going right 3. Now, right here, we do not have any left, right, up, or down transformations, but we have a negative in front of x squared. That is a vertical reflection over the x-axis. That's too much to write down. So I just abbreviate reflection over the x-axis. It's gonna open down. Any number in front of x squared here, that's gonna, well, any number greater than 1, any number greater than 1, that's gonna be a stretch of 2, vertical stretch of 2. Any number in between 0 and 1, or a proper fraction, that's going to be a shrink or compression, means the same thing, of 1/2. And then here we have a couple of transformations going on. We're going right 5, and we're going up 3. Okay, feel free to pause the video or go back to my Canvas page and fill that in on your own time. Now we want us to graph the function using a transformation table. I'm going to start by listing what the vertex is. This is called vertex form. The reason why is because it's very easy to identify your vertex. In order to do that, we're about to find our vertex. Look inside the parentheses with the x. We have to solve what's in parentheses with the x. X plus 4 = 0. If you do that, we get -4, comma, and then whatever number's out here to the right, -7. That's our vertex. This right here is the parent table of y = x squared. You might need to commit that to memory. I want to commit this table to memory. And now we're going to build our transformation table. Starting with this box here, I'm going to list the transformation that is occurring to x. So looking in the parentheses, remember, we're going left 4. So we're going to do x minus 4. Now, the other transformations that we have in this graph is a vertical reflection over the x-axis, a stretch of 2, and we're going down to 7. All of that is going to impact our y. So starting with this, we're going to write -2 times y, and then -7. So when you go to graph these, here's how you're going to use your parent table. I'm going to cover up the y values for now. I'm going to take -1, and I'm going to substitute it here for x, and then subtract 4 from it. -1 minus 4 is -5. Now, if I took 0 and plugged it in, 0 minus 4 is -4. And now take 1 and substitute it for x. 1 minus 4 is -3. Now cover up the x values of the parent table, and now let's look at the y values. Let's take 1 and substitute it for y here. -2 times 1 is -2, and -2 minus 7 is -9. Let's take 0 and plug it in. -2 times 0 is 0, and 0 minus 7 is -7. Let's take 1 and plug it in. -2 times 1 is -2, and -2 minus 7 is -9. And now we can graph our function here. -5, -9. -4, -7. and -3, -9. Our domain, -infinity, +infinity. Our range from minimum to maximum. Minimum, this time, we're coming from -infinity, and we are approaching our maximum, which is that value right there, our vertex. And now minimum and maximum. Well, we're never going to go any higher than that point. So we have a maximum at the y value, -7. I do not have the time to go over examples A and B. If you need any help with those, please talk to me. I'd be happy to help you. The last one that I have time for is this one here, example C. We're going to convert the following from vertex to general form, also known as standard form. Standard form, general form is this ax squared plus bx plus c. So we're converting from vertex to standard. Here's how you do it. You write down what this is. Okay, so here was our function in vertex form. You're going to have to take that parentheses that's being squared and write it twice, because anything that's being squared means you have two the exact same thing. Now we're going to have to FOIL x times x times -1, -1 times x, -1 times -1. Bring down the +2. And now combine like terms. And just put y equals in front of that. Now we have converted it to standard form or general. Have a good day.